To determine the rotational inertia of a football, we attach it to a rod of negligible mass that can spin freely. The bottom of the rod is a cylinder with radius r. Okay, let's record all of this. R, mass m, and rotational inertia 1/2 mr squared. A string with negligible mass is wrapped around the cylinder. The other end of the string is wrapped around a frictionless pulley with negligible mass and connected to a block of mass 5m. The block is released and falls with an acceleration of 1/2 g. Determine the angular acceleration of the cylinder. Okay, so let's take a look at how this motion would connect these two things. Well, basically, if you look at like kind of an aerial view of this little cylinder thing, okay, has a radius r, okay, and the rope, let's assume, is sort of like attached, so it goes this way. And we'll say there's a tension there from that force, and that's causing a torque. It's causing it to rotate on an angular acceleration. So let's see if we can figure out what this. Well, one thing I could say is that if I connect that this guy, like when you think about the rope unwinding, like the amount of rope that's unwinding here has to match the rope that is like kind of falling, if that kind of makes sense. So you think of the rope here, the acceleration of this rope has to match the acceleration of this rope. So this rope is unwinding at an acceleration of 1/2 g, okay? But the angular acceleration then is connected to, it's a over r, right? This is how we calculate angular acceleration. So then it's just 1/2 g, 1/2 g divided by r, or g over 2r. I can just write it like that. I just moved the r to the top, or 1 over r, or move the 2 to the bottom if you don't think about that. So that's A. It's pretty easy. It's just a connection between the two. Now determine the rotational inertia of the object. This should be like the football, really. The football. What is the rotational inertia of this football? Okay, so now we have to look at like this entire system. And let's think about how what connects the rotational inertia is the net torque equals I alpha. Okay, if I look at this whole system. Well, the net torque, there's only one thing that's causing a torque, and it's the tension in the rope here. Okay, what torque? It's the tension times the radius, because if I draw an r vector from the axis of rotation here, it's just r times the tension is the only torque that's acting on the system. Now, what's the I? The I is the rotational inertia of the football as well as the rotational inertia of this spool. So that would be I unknown, I'm going to say I of the football, plus 1/2 mr squared, which is the I of this little cylinder here, times alpha. Now I know alpha, I can try to solve for IF, but I need to know what the tension is. Well, I can get that by doing a free body diagram of this guy down here, 5m, because I didn't worry about that, because that's the only other thing that involves the tension, right? Now, 5mg, force of gravity. Now, 5mg doesn't equal t because I have to look at the net force of that guy. Net force equals ma, and he's accelerating downward. So I would say downward is positive. 5mg minus the tension is 5m times a. Okay, but we know that a is equal to 1/2 g, so this is 5/2 mg, right? Because I replaced the a with 1/2 g. And so you can solve for the tension here. If I move I subtract 5mg, I get negative tension is minus the 5mg is 5/2 mg minus 5mg. And if you do 5/2 minus 5, you get negative 5/2 mg. So that means the tension is equal to 5/2 mg. So now I know what the tension is. And now I know every piece of information in here. I plug the alpha into there, and I plug the tension into there, and so I get 5/2 mg times r is equal to IF, the football, plus 1/2 mr squared times g over 2r. Okay, so I'm going to multiply both sides by 2r over g to get rid of this thing here. So this will cancel with that guy, or on the right side, this basically gone. The g will cancel with this guy, and then the 2 will cancel with this guy. So I'm left with 5m. Oh, there's a r squared, right? Because the r times the r there is equal to IF plus 1/2 mr squared. So then you can just do IF by subtracting 1/2 mr squared. This would be 10 halves minus 1 half would be 9 halves mr squared. Okay, so that is the rotational inertia of the football.